Hello guys, welcome to our new video tutorial series of operating system, and in this video I will explain a process and importance of process in operating system. So you have heard the name process so many times. So I will explain you what is process. So process is a running instance of a program. It includes the program code and its current activity. Think of a process as a task that your computer is working on it. For example, when you open a new web browser, your computer creates a new process for it. So why our processes are important? So there are three things that every process have. Resource management. The operating system manages process to ensure each gets the necessary resources like CPU time, memory, and input output devices. So whenever you open a web browser or any process, it will deal separately. So you have heard that whenever you open a new web browser, every time like you can open up to 50 or 60 Chrome browser page at a time. But when you see that when you try to open more, it will get stuck and it will crash. So it your operating system cannot handle so many processes at the same time. That's why it crashes. It depends on your computer memory and your uh, how strong your CPU is. It really depends on that. So isolation process running independently. So if one crashes, it does not affect others. This keep the system stable. So whenever your process crashes, like your web browser crashes, it doesn't affect your other processes on computer. On Word, maybe you open a Word or a PowerPoint, it does not affect all of the processes. Multitasking. By managing multiple processes at once, the operating system allow you to run several programs simultaneously, like listening to music while writing a document. Yes. So if I open a task manager, and you can see this is all the processes running in my computer, and right now it consuming 100% of my CPU, like 90.8% using this program compatibility. Like I have Chrome browser, web pages 8 browser open right now, web pages. I have antivirus, like it changes, it affects the performance of your computer. 58% of the physical memory used by active processes, 7% days, and 0% networking. So if I want to close or end the process, I can simply close by doing this. Like if I close the antivirus, I just end that task and it will stop consuming CPU memory. So this is your um, task manager performance. Like CPU is consuming, I have 12 GB of memory and only 1 to 3% of SSD memory is used. So like I stop the antivirus and it start consuming CPU memory. If I Yeah, so it's consuming 0.1% of the memory. So if I close this task manager, okay, so as you can understand the basic concept of a process, so I will explain more about process and the structure of a process in memory. So process components in memory. First thing is text code segment. This is where the actual code of the program is stored. So whenever you run a process, definitely there is a code of that program is stored in some place. So that place is text segment. Another place is data segment contains global and static variables that are used by the program. So we have global and static variables in our programs in C or C++, which used by all the program. When you run the program, global variables are accessible by all functions, and all the program can use that global variables. Then there's a thing heap used for dynamic memory allocation. When a program requests a memory example allocate in C, it is located from the heap. So there are two types of memory. The one thing is dynamic memory allocation, like whenever a program requires some memory at the runtime, like when you already run that program and you are allocating memory to a variable, it will store in heap. And there's another thing, stack, first in last out, last in first out. Like this is how stack stored its data. Stack stores temporary data like function parameters, return addresses, and local variables. Like all the local variables we used to create in our program is stored in stack. Each time a function is called, a new stack frame is created for it. Like whenever we create a function in our programming, it will manage by a stack. Then there is a called registers, small storage location within the CPU that holds data and instruction temporarily during execution. So registers are very small in memory. It mostly uses the instructions and that managed by CPU and its whole data, like where to run next or something like that. Then process memory layout. As I already said about the text segment contains the executable code. Data segment holds static and global variables. Heap grows upwards, used for dynamic memory allocation. Stack grows downward, used for function call management. How processes are managed. The OS uses a process table to keep track of all active processes. Each process has its unique PID, process ID. So, like whenever we run any process, it will create a new PSID for that particular process. So the OS schedule processes use a algorithm to decide which process get the CPU and for how long. So like if you are using multiple processes at the same time, like you open a Chrome browser, you open a Safari, or maybe Mozilla Firefox, you open a Word, you open a PowerPoint. Every process needs like all the um, CPU memory allocation. So how does it run simultaneously without affecting other processes? So it will give like shifting. It can be managed by OS schedulers. There are so many OS schedulers. So every process has its own time. When it's get done, it will move to next process. Or if any big process, like it will take a longer time. Maybe you are downloading something, or maybe you are running a big program. It will, shifting through the schedulers. So it will give some time to one process A, then shift to B, then shift to C, and then again shift to A. So it will run like within a millisecond or microsecond. So we cannot see, with as a user, you cannot see the that it was shifting from one process to another process. But in actual time, it was. So this is a image that shows memory layout of a process. So in a process we have four types of memory. I already told you, one is stack, it's scroll downwards. So Whenever we put something in stack, it will, you know, first last in, first out. So it's just like in queue, first in, first out. Whenever comes first, it will go first. But in stack, the thing we put in last, it will come first. So it will grow downwards. So if you put something in stack, it will go here, and then second level, then third, and fourth, and fifth. And when you pop out from the stack, it will the first of the element on the top of the stack. Like if you put a program or something or variables, it will the last variable put in stack will come out first. So it's last in, first out. The heap grows upwards. So if you store something, it will store in the below, then up, and then second, then third, and it's go upwards. And there's a data segment, and there's a text segment where all your code stores. So I hope you understand the process in operating system and its resources and how it's managed by the operating system. I will share more about the process and all the operating system, how operating system manages processes. We can demonstrate with the program as well in next video. So stay tuned for the next video. Hope you like my video. Please like, subscribe, and share. Thank you.